Hello, my name is John Dominic. This is my submission for the calculus video 2 and 3 extra credit videos. This is my 4th time recording this because I messed up the last two with the England. Let's hope it works out this time. So in this video, I'm going to cover both the videos for 2 and 3, and I'll go over all 4 topics. So the first topic we're going to go over is chain rule. And chain rule can be very simply set out to look like this. Equals f prime of gx times g prime. So if you ever have a problem like this, your end result will look like this. Let me show you an example because I find those easier to look at the formulas. So let's say you have 6x plus 4 to the power of 3. Your f would be all of this. And then your g would be 6x plus 4. Now then, how would you find the derivative of it? So you would move 3 to the front for 3. And then you keep this the same, 6x plus 4. And then you multiply that by the derivative of 6 over 4, which would just be 6. And then you can just leave it like this, or you can simplify it. I prefer to leave it like this. I find it easier. And that's like the very basics of chain rule. It's very simple, not super difficult, but it can get more challenging with different problems. Let's go through some of those. Let's say there's something in front of the original problem. Say you had 6 4x plus 2. Let's do 4x squared so we don't show how it works when you have something like that inside. And this we have this to the power of 3. So it's very simple still. Move this to the front, so it becomes 6 times 3. It's the same. 4x squared plus 2. And we'll try to write the derivative. Times 8x. Again, very simple. Not super complicated. Just like that. And let's go over how it would work with logarithms and e. Starting off with logarithms. Still very simple for this. You would have, so you have log 2x. Whenever it's logarithmic, it's always log, you representing the inside, and then it's 1 over u times u prime. And that's how the derivative of logarithmic. For a problem like this, 2x would be 1 over 2x. Other changes, but then the derivative of 2 is just 2. So you have 2. And then you multiply that, so which would equal 2 over 2x. If you had a derivative that was that didn't have an x, say log just 2, then it would be 1 over 2 times, what's it called? Logarithmic of, it's just non-existent basically. So it'd just be 1 over 2, stay the same. You're going to do anything else to it, you just do it there. And that's the basis of doing it with logarithmics. And then you can have like bigger numbers. Let's do it with Let's do it with a bigger log. And these markers do not work. Let's do log 2x plus 4. So, again, same thing, 1 over u. It would become 1 over 2x plus 4 multiplied by the inside, which is just 2. So it would be 2 over 2x plus 4. And you can leave like that. Let's move on to E. So you had E, oh my God. This is even worse. Where'd my third marker go? There it is. Ugh. Okay, I don't know anymore. Let's go back to the first, I guess. Yup. HU, you know. Funding who? Not here. Let's do E2x. This is one of the problems I have to on the PAC exams. So, when you have E2x, you keep all of this the same. So it would be E2x multiplied by the derivative of 2x, which is just 2. So this problem must be 2 E2x. Very simple, very easy. Let's do a bigger one. Give me a second to find the marker. Sorry for the wait, I found the other marker. So that's the problem. E2x plus 4. Same concept here. It would just be e2x plus 4 times 2. So 2e2x plus 4. Very simple. E is very easy, but on my exam, for exam 2, I had a lot of trouble with specifically LLM questions. E wasn't as bad, but like it was very confusing for me. And I know it now. That's nice. Now then, that's about it for chain rule. There isn't really much else to learn with it, I don't think. I'm gonna look up some chain rule problems though. Some chain rule practice problems. Okay, nice. I found a couple. Let's start off with 6x3 plus 7x 4. This is a very simple one. It's just going to be 4, 6x3 plus 7x multiplied by the root of the inside, which is going to be 18x squared plus 7. Very simple, very easy. And then let's move on to the next one, which is what does that say? Okay. 3, 1 minus 8, I believe. 8z. So we're going to remove the radical, and that's going to be 1 minus 8z 1 over 3. Again, pretty simple. It's going to be 1 over 3, 1 minus 8z. Oh, before I forget, there's one biggest issue with chain rule. I always forget to add the power rule back on top here. Do not forget to do that. I forget a little too much and it becomes an issue. But you must remember that. So 1 over 3 minus 3 over 3, which is 2 minus 2 over 3. So yeah, minus 2 over 3 multiplied by the derivative of 1 minus 8z, which is just negative 8. Boom. Yeah, chain rule, pretty simple. Pretty self-explanatory. One of the easier ones. Let's move on to the next one. That is implicit differentiation. Also not difficult. So, implicit differentiation is used when you have multiple terms, which is the term to find the derivative. It's also very, very simple. The main thing is just to use the power rule. So, let me think about the practice problem for it. You're really just trying to find dy dx. That's the big thing here. In class, we taught us to use like u prime as the main method, but the way I do it is using just dy dx. It's very simple. Our practice problem would be like 2x plus, let's go with 3y equals 4. And then find the derivative of this, which would just be 2 plus, and now here's where the main thing comes in. And instead of just find the derivative of 3y, you're going to put the derivative of 3y, which is going to be 3, and then you're going to put dy dx. And then, of course, this is 0. Now then, dy dx equals 2, divide by 3, divide by 3, dy dx equals 2 over 3. Very simple, very easy. That's basically the whole thing behind input differentiation. It's not very difficult, as long as you know what you're doing. I don't know if I spelled that right. And then let's do a bit of a harder problem. Let me see if I can find some so I don't, you know. This one looks nice. So it's x cubed plus 4xy plus y equals 13. Again, very simple. Though it is good to note that sometimes you'll be solving for x and not y, but typically, at least in this class, we've always solved for dy dx. So that's what we're doing in the practice problems. Now then, the derivative. 3x squared plus, that's the tricky part. You see this, like the 2, like how you do product rule, right? So this is f, this is g, so it would be 4 f prime times y, so 4y. Because you have it from the derivative of y, there's no reason to add dy dx. And then you're going to add that with 4x. And now you find the derivative of y, which is just 1. So instead of adding that, you put dy dx. And then, so you're going to add 4y plus 4x dy dx. Very easy, very simple. And then let's add now the derivative of y, which is just going to be dy dx. Equals 13. Beautiful. Now then, oh, not 13. Derivative of 13 is 0. So, 4x dy dx plus dy dx. You're going to want to put dy dx on one side of the equation, and then 3x squared plus 4y on the other side. And then now you're going to take out dy dx, which would be dy dx 4x plus 1 equals 3x squared plus 4y. And then just divide the entire equation by the entire left side by 4x plus 1, and then divide the right side by 4x plus 1. The final equation for this is dy dx equals 3x squared plus 4y over 4x plus 1. Again, implicit differentiation is very simple. It's very easy. As long as you have the basic concepts of it, you can really do it very easily. Yeah, that's really about it for implicit differentiation. Most of the problems are very similar to this, with not too much to do, at least for the second exam. It was a little different in the final exam, but for the pick of this video, I think it should be enough. Now then, let's move on to video 3 and its information and contents. Exam 3 is the exam I had to go shovel on. Specifically with definite intervals. So let's start with indefinite and move on to there. Cool. This is going to specifically focus on U substitution, which I had the most trouble with. U substitution is basically, it's very simple. You substitute in U for whatever is in the equation, and then you find the integral, and then you put U back in afterwards. It's not particularly difficult. I feel like it's better to show some practice problems than to explain it myself. And we'll start with indefinite integral practice. Okay, I found a nice one. I understand integrals by themselves, which is why I'm not explaining the entire concept of it and more just like behind the solution of it. Because integrals by themselves is not hard. Is that minus or plus 12? It's minus. And then 4x cubed minus 12x. And then to the power of 4. Cool. Not too bad at all. dx. Alright, first, U substitution, you have to find the U. There are two potential U's here, so what I'm going to use is have U be U equals 4x cubed minus 12x. After you find your U, you then find the derivative of U, which is du. du equals 12x squared minus 12. And then you have to put dx afterwards. Cool. And then you need to find